Hi everyone, I'm Ruth, and we are going to talk about whether privacy is an essential requirement for AI. We will specify what must be proven to ensure purpose binding, data minimization, and resistance to inference attacks. We will map where zero-knowledge proofs, attestations, and TEs each apply preferred commitments over raw logs, and align controls with clear retention and erasure guarantees. So to start, I wanted to refer that right now, over the internet, by default, we share a lot of data without even realizing, especially when interacting with AI. So my first question for the panel is, what must be provable at minimum for privacy by default to be real?
Hey everyone. So to start with this conversation of privacy alongside the basic standard needs of what needs to be private as such, so we firstly talk about the identities, right? So we have been in the normal blockchain or Web3 space as such, we have been talking about privacy preserving, KYC, identities and all those things. And as we move into the world of agentic AIs where agents try to do everything for us, they try to do the trading, they try to do the DeFi and micropayments and all of those. So I think having an identity for each AI agent, as the whole topic is, and having privacy preserving ways to validate the concerns of an agent, or like the computational boundaries of an agent, or what kind of inputs it's a stake in, all of those. So those are the bystander, the default thing, I guess, which we should be trying to achieve in the agentic AI side of things.
Hi everyone. So I kind of agree on this side. So about the zk-KYC and stuff. So I think so zk in start itself provides the privacy, though it is not fully decentralized because right now we don't have the computational power and it is quite expensive to do everything on chain. So I think so even you guys are doing off chain and proving it and then bringing the proofs on chain. So I think like the first, when we talk about the micropayments and everything which we are looking at right now. So every transaction which is done for anyone who is doing it on chain brings a certain transaction or an address. But if it is fully decentralized, privacy focused, or maybe if the proofs are generated off chain and the on chain proving is used a privacy method, so that time we can actually hide all these data and we just know how many users have clicked it, how many users have approved it. So that is the first major focus why I think so. Not now, but in future, everyone will be using zk either in-house or they will be using zk outside. Like I don't know if zk Verify is providing it, Boundless is doing it, and there are many other providers who are providing you zk proof. Now coming to how we are looking into the privacy matters right now based on AI, because initially when all the AI data was trained, like LLMs and stuff, it was trained on a basic model where there is a human who tries to train the data with all the raw data which comes to it. Now FHE and others are trying to get it solved where you provide x plus y is equals to z, but you don't know the components, but the answer still comes to z thing. So when this encryption works on the data side, so how it works is whenever I provide a x amount of transaction which goes into a pool, that pool brings out a value certain which goes into the blockchain without disclosing every information, which is actually also important just not for the AI but also for the RWS. Let's say if I'm not a citizen of US and I want to buy a property in US, so either I have first option, I get a proof via passport and stuff, or there is another which is like zk-KYC. I have a proof, but still it is under the regulations right now. But this can be a major use case where we just don't focus on the AI or the inference side, we focus on the real use cases.
Yeah, to that point, I think you don't get to have total privacy even with zk when you use AI. Because simply, I mean, at some point the LLM needs to know your query, right? So that gets to the cloud, that gets in plain text, right, interpreted. What you can do, the best you can do when you talk about the LLM is to make it auditable as much as you can. So anyone who gives permission to use the data in a certain way, or didn't give permission, say, hey, I want my data to be private, that entity, for example, OpenAI, they can prove to a regulator that they only trained the new model using data from customers who voluntarily say, yes, I'm going to allow it, and that no one that says no, that data is not included in the data set for training. Because if you want really final privacy, you need to run the models locally, which is very expensive to run LLMs. But you can make it much more auditable. So this proof can help in that process, because before you train, you can run a zk program on top of the data and verify, okay, all this data is actually, the permission was given before it goes to probably a TEE for training or inference. That's the best you can do these days because of the performance. And I also think that it's really important to have a decouple of the cloud provider of the AI and also the client that you use to interact with it, right? Because if you want to give permission, ideally you want to sign that consent in a certain way that you can put it on the blockchain, at least the root of the consent you're giving, so it can be independently verified as well outside of a company like OpenAI.
Yeah, I think first we need to say privacy is important for everybody, especially when we use chat with like ChatGPT or other LLMs. When we want to book some like flats or maybe hotels, maybe we don't want to expose too much privacy, so we need to protect it. And regarding the approaches, as we already mentioned, maybe zk, maybe TE. Actually, I would have some other thoughts about this, because when we interact with the big large language models, actually it's really hard to apply TE or zk. Zk is even I'm doing zk things, but I have to say it's not practical today. Yeah. So maybe what we want to protect our privacy means we don't want our text, our conversation, or our prompts and response are not bounded to specific individuals. So like we can use some like de-identification or some other anonymity techniques over there. Yeah, so that would be maybe more practice. And get back to TE and zk, I think TE is more like for the integrity of the computation, because maybe everybody heard about that. Maybe 2 or 3 months, there will be another vulnerability from the TE, no matter SGX or other TDVM or other TE hardware. So for the zk, of course, it can be used to protect the privacy today. But yeah, of course, if we still need to consider the scenarios. So for the training or inference of the AI model, so it's really hard right now. Yeah, so that's my point about this.
I think it's a good point. Like, what are we supposed to do with zk for privacy? Like, even if we had like a super performance zk prover, which we don't, right? You can prove that a model was trained in a certain way. That is not privacy. You can prove certain inference was done in a certain way. That is not privacy. It's all about not just integrity, but just knowing the provenance of the training, the model, of the inference. But even you mentioned the TE. I mean, it's the best you can do. It's not invulnerable. We know it's not, but at least reduces the circle of trust that is required to operate.
Okay, interesting. So yeah, I wanted also to expand a bit more on this topic on zk versus TE, and how should they be applied in each case, and state like some boundaries between both specifically.
Thank you.
Yeah, sure. So I have been working on both zk and TE side of thing along with zk Verify. So we have recently even partnered with Fala and Secret Network for try to expand our reach with TEs, with more AI agents and all of those things. And when I see the most amount of defection, kind of the boundary among zk and TEs are the computational level. The amount of computation that you can do inside zk is kind of very minimal right now, and like it's very time taking and all those things. When you want to do a large amount of computation, and if you need real-time inferences out of your computation, TEs are the way to go right now, at least, because we don't have a very scalable ZK backend right now. We do have a lot of fast proving methods, but none of them are close to what we want to achieve till the point. So T's are kind of leading in that. Coming to the AI side of things with the agentic AIs and all this side of things, so we know there are frameworks like EZKL, Giza Tech, who have been trying to make zk-ML frameworks, which converts your machine learning models to ZK circuits, to say. But again, that's also has a boundary of computation. You cannot convert an OpenAI model to a ZK circuit using that, right? So maybe some niche ML models, like if I want to make an ML model to scan my face or to do some small trading, maybe that's fine. But if I want to do some real-time trading, or if I want to run a full ChatGPT inference, then T is the way to go. So maybe that's the broader framework of difference. If you want to do like less computation but a really strong cryptographic guarantee, then obviously ZK is the way to go. But if you want real-time inferences and some large computations, T's are the way to go for now.
Awesome. So specifically from my side, on the Manta side, if you all know that initially Manta was launched as a parachain, privacy focused back in 2021. That time everything was like fully private on chain. So let's say if a asset is bought from other chain into Manta ecosystem, so that can be transferred, used privately without knowing how it is used. So that was initial start, but then we got to know about Tornado Cash. Manta was based out of US. So we shifted from the privacy, fully private, to a ZK proof narrative. Right now we are majorly focused on the narrative side of ZK rather than just privacy. But now we have a new use case, which is about the PayFi by using privacy. So let's say if the government of US, North Korea doesn't allow you to use privacy preserving payment system, so a user or a B2B SaaS model can use a KYC model which is proved by ZK, and then that people can use PayFi on a private matter. So let's say if a bank which doesn't want to disclose the data for their users, what they are doing right now. Let's take an example of a Swiss bank. Swiss bank doesn't want to disclose anything. Swiss bank can register under the KYC. They can use the PayFi with the anon addresses which is not published fully on chain. Proving is done off chain, and only the final proofs are submitted on chain. So this is how the ecosystem is initially started. I think so right now even banks and institutions are looking into the privacy and how we can sustain the ecosystem first with the B2B models, then to B2C, because it is more about the adoption, but it also comes with the regulation issues. So to work with the regulations, to support them, if it is private, so it might be difficult to convince the governments as well that it is private and we can't submit all the data. But if we actually generate some proofs with the help of T's or maybe ZK or maybe FH in future, so that will be the time when we can have a B2C models as well. So right now it's majorly focused on the B2B side, payments, infrastructure, maybe DAO, treasuries and stuff, which people doesn't want to disclose right now outside. So that is the major focus for us.
I don't have any specific really to say.
Okay, yeah, I was.
Could you repeat the question again?
What are the big difference between using T's and zero knowledge proofs around AI?
Oh, yeah. I mean, it's all based on or where the trust is. Like a zk is fully mathematical, so you don't have to trust anyone. You just have to trust that the math checks out. But with a TEE, you have to trust the manufacturer of the device, and even that, anyone who's physical access to the microchip, we know that in theory they can also break it and break that assumption of security, right? So zk is better, much better in security. It's just the performance is not there yet, even though we have improved like 100x in the last couple of years.
Yeah, I think first of all, I know some projects right now, they are using the TE to do the model training or model serving. Yeah, that's okay, I think. But from the privacy perspective, I think we should care more about like our unique identities. So that's where the ZK can help here. I know a lot of like wallet projects or social login projects that they use the ZK, yeah, especially the on-device proving to protect the individual's privacy. Yeah, that's would be yeah, very helpful, I think. And my point about maybe the boundary to use TE or zk is very clear. That's if you want to protect your privacy, use zk or use some other like FHE or MPC techniques. If you want to achieve the integrity or want to protect the integrity of your program, yeah, TE is okay.
Okay. Yeah, it totally makes sense. Now to finalize, and I just wanted to ask for you to just briefly mention one policy change that you would implement in 12 months to make dignity preserving AI by default.
Yeah, so like as the first policy would be most probably having identities for AI. So all the AI agents right now, they don't have any identity of its own, so it's kind of an untrackable ecosystem out there. Anyone can just copy the same agent and try to do some bad stuff as well. So maybe having each agent having its own identity, maybe through a zk way of generating a unique hash of each agent by hashing the layers also, that's also work. But we need to have a unique ID for each agent for sure.
I think so. It can be privacy data DAOs. So just like mixers in privacy, we can have a data for like privacy, like mixer for privacy data DAOs, so that every information which goes inside is a mixed, and we never know about the particular individual autonomously, but we know the general status on that particular thing.
The one thing that I will request is just every time a new model is being trained, I think the provider of the model should also publish of zk or a zk proof of where the data is coming from, and if they had the proper permission from the users, explicit permission, and verifying like these signatures and all that.
Yeah, I think you guys
Covered.
Okay, that was a great chat, and we just finalize it. Thank you.
You.